Welcome to section 7.3. Today we're looking at formulas involving polygons, and we're going to review a little bit on what a polygon is. We'll also talk about how to name polygons before we get into applying the formulas. So a polygon is a plane figure that has the following properties, and all three of these things must hold true. It has to have at least three sides, must be completely enclosed, and can only be made of segments. No curvy pieces, no arcs, nothing like that. There are several polygons that you are going to need to know the names of. I'm going to have you memorize these. Some of them you're probably going to know already. Three sides is a triangle. We spent an entire chapter about that. Four sides is a quadrilateral. We spent a good portion of a chapter covering that as well. In addition to that, five sides is a pentagon. Six sides is a hexagon. Seven sides is a heptagon. Eight sides is an octagon. Think of a stop sign. Nine sides is a nonagon. 10 is decagon. We can remember that because a decade is 10 years, so a decagon is a 10-sided shape. 12 is dodecagon. If you think about decagon being 10, and to that we're going to add 2, so it's a dodecagon. And same thing with 15, pentadecagon, because you have a 10-sided shape, and you're adding 5. Anything else that we don't have a specific name for, we're just going to call an n-gon, n being the number of sides. So let's say it's a 27-sided shape. We're going to call that a 27-gon. Now here are the formulas that we're going to be using in this particular section. Sum of interior angles. So if we know how many sides a polygon has, we can find out what the sum of all of the angles that are inside the shape is going to be. And let's click on, oops. Go to the diagram or the interactive piece to this. So here we have a interior angles of a polygon. So if you look at this is a pentagon, 5 sides, and I can change this so that it's not a regular polygon. We'll talk about what that is more tomorrow. But all of the angles added up are going to add up to 540 degrees. So I can drag these around. I'm changing these angles, but you notice my sum is still the same. It's still 540 degrees. I could change the number of sides. I can make it smaller. A quadrilateral. Notice moving the angles around doesn't do anything to the sum. It's still 360 degrees. A triangle. We already know that all the triangles added up are 180. So the smallest polygon we have is a triangle, and that's 180 degrees for the interior angles. The next biggest is a quadrilateral. It's 360. The next one is a pentagon, 540. And the next one is going to be a hexagon, 720. So we can drag those angles around. Nothing's changing. It's still that same sum. So it seems like what we're doing every single time is we're adding the same number every time we add a side. So 720 gives me 900. And I bet the next one is going to be 180 bigger than 900, so should be 1080, and sure enough it is. And the next one would be 180 bigger. A nonagon is going to have 1260. So there's a formula that we can use that will tell us every single time what the sum of the interior angles is. And that formula is S sub I, which means sum of interior angles, all of them added up, is n minus 2, so the number of sides of the polygon, subtracting 2, times 180. Think about that, the triangle is the smallest one, so 3 minus 2 is 1, multiply that by 180, you get 180 degrees. So every time you add a side, you add 180 degrees to the interior angle sum. Pretty consistent with that. Similarly with the exterior angles, there's a way that we can always find out what they are, but unlike the sum of the interior angles, the sum of the exterior is even easier. So we have here a 5-sided shape, and if we add up all of our exterior angles, it looks like we've got 360 degrees. No matter what I do, the exterior angles add up to 360. I'm going to make this regular and kind of show you why this works. If we add more sides, notice my sum doesn't change. It's still 360. If I add more sides, my sum doesn't change. It's still 360. And if I keep going, if you look at what's happening to the shape as I add more sides, it looks like it's getting closer and closer to being a circle. keep going forever, and it's going to get even closer and closer to a circle. So the key to this, though, is understanding that when you've got an exterior angle sum, it's always 360 degrees, no matter what. So the sum of the exterior, S sub E, is 360. Doesn't matter how many sides you have. You could have 18,000 sides. The sum of the exterior angles is always 360 degrees. The number of diagonals is the last formula that we're going to cover. And a diagonal is a segment that connects non-consecutive vertices of a polygon. So we're going to go from corner to corner inside the shape. And we have a formula for this. And this one's not as easy to figure out, so we'll kind of walk through the steps on what it is. But let's start with, let's actually start with a triangle. You notice in a triangle we have no diagonals at all. There's no way to get from this corner to this corner going through the shape, and this corner to this corner going through the shape. If I add a side, though, now I have a square or four-sided shape, a quadrilateral, that's going to have two diagonals going from this corner to this corner and that one to that one. And I can make this irregular, and it's still going to do the same thing. I still have two diagonals. If I add another side, though, now I have significantly more diagonals. So a pentagon has 5 sides, and in this case, it also has 5 diagonals. And that's the only time that happens, that the number of sides and the number of diagonals is equal. So when you have a pentagon. Now, as you would expect, if I add more sides, I'm going to add more diagonals. So you notice when I had a square, I had 2 diagonals. Pentagon, I had 5 diagonals, so it went up 3. Hexagon has 9 diagonals, it went up 4. Heptagon has 14 diagonals, we added 5 more diagonals in. Octagon has 20 diagonals, we're adding 6 to that. And I bet you the next one will have 27, and probably 35 because I'm adding 8, and probably 44 because I'm adding 9, and so on. So as you can see, as we add more diagonals, we're adding more to that previous sum. So our formula for the number of diagonals, it's a little bit more difficult to figure out from the thought process that we have here. But the formula is n times n minus 3, all divided by 2. So it's the number of sides times the number of sides minus 3, and that's why a triangle has 0 diagonals, because it's 3 minus 3, which is 0, and divide all that by 2. And that'll tell you how many diagonals a polygon has, whether it's a pentagon, an octagon, a 27gon, whatever the number of sides is, you can find out the number of diagonals. Now, these formulas are important for you to memorize. I might give you a question on a quiz or a test where I'm asking you for the number of diagonals of a 25gon. You do not want to be drawing those in, because as you can see, it's going to be a very large number. 25 times 22 divided by 2 is a very large number. So the formulas are better because you can just plug them in and go.